All right, guys, this is Mr. Morgan. What we're going to be doing today is we're going to be looking at using the Pythagorean Theorem and its converse. Okay, so the first part of the video will be focusing on just using the Pythagorean Theorem, and then the second part is going to be focused on the converse. All right, so if you look at this example here, what we're doing is we are looking to see what the missing measure of some side of a right triangle would be. Now keep in mind that the Pythagorean theorem will only work on right triangles. Okay, so what we're going to do is we're going to go over the equation first. We know that a squared plus b squared is equal to c squared. Now what does that mean? That means that these legs or sides of your triangle are going to be both a and b. The largest side, or the hypotenuse, is always going to be your c value. And what you're going to do is you're going to plug in the value that you see here to find what this missing piece would be. Now, the missing piece could be C. The missing piece in this case could be our B value. And the missing piece could be our A value. Now, again, if you notice here, this is A. We have put their A value here in blue. B, our B value. So if you notice how they correspond. Okay. Now, what you're going to do is you're going to square each of the values. So 24, I'm going to square that. That's going to give me 576. I'm going to look at my value of B, that's 7. I'm going to square it. That's going to give me 49. Now, once I simplify and add these together, that's going to give me my value of C, okay? Or C squared, I should say, which is 625. Now, keep in mind that C squared, some value of C times some value of C, also known as C squared, is going to give me 625. So I'm going to put that into my calculator, take the square root, because that's the inverse, take the square root of 625. And that's going to give me 25. So if I multiply 25 times 25, or 25 squared, that's going to give me 625. Now let's go ahead and look at a problem. Now the two problems that I'm going to be looking at are dealing with two different triangles. Okay, the first of which has dimensions of 30 feet and 40 feet. As you notice, it is denoted that it is a right triangle based on the fact that there's the square here in the corner. And then we have another triangle, okay, which we show has dimensions in terms of 40 inches for one of the legs. We have the hypotenuse, which should be the largest value, at 41. And then we have a missing value over here. We're going to call that B, okay? So your B value is actually missing, okay? So what I'm going to do is I'm going to go ahead and switch over to my drawings page. So I'm going to start here by writing in my equation, which is a squared plus b squared is equal to c squared. Okay, now I'm going to substitute in those values that I have there, and I'm going to change the color of my pen. I'm not sure if you're able to pick up on that. Okay, so I'm going to associate this one as my a value. Doesn't matter which one I pick to be a or b, just as long as I don't pick the c value. I'm going to assign this as b. So I have 40 squared plus 30 squared is equal to c squared. Right now, I don't know the value of my c, okay? So I'm going to simplify that out. Once I simplify that, I know that 40 squared is going to be 1,600. 30 squared will be 900. And that's still going to be equal to c. So what I'm doing is I'm maintaining all of my values as I continue to simplify. When I simplify these two and add these two together, that's going to give me 2,500 is still equal to c squared. So basically what I'm saying is that some value of c times some value of c is going to be 2,500. So I need to figure out what that value is. I'm going to do that by taking my square root. Okay, the square root of 2,500 is going to be 50. So I know that my value of c is going to be 50. Okay. So the way that I test this out is I know that there is one leg that I've said is A. That's going to be 40 feet. I have another leg, which I'm going to call B, which is 30 feet. And then the hypotenuse, okay, also known as my C value, is going to be my largest one at 50 feet. Okay, so that's one. All right, so let's go ahead and look at our next one. The next triangle here, I'm going to start off again with my equation. The equation is a squared plus b squared is equal to c squared. Okay. I'm going to continue in. I have my leg A, which is 40 inches, leg B, which is unknown at this point, and then I'm going to abbreviate hypotenuse is my C value at 41 inches. Sorry, move that up a little bit. All right, so let's go ahead and start with our pencil. We have 40 squared, because that was A, plus B squared. I don't know what my value of B is just yet, but I do know my value of C, which is 41 squared. Let me erase that. And what I've done is I've taken off my units for now, but I know that I need to come back to them. Okay? So 40 squared is going to be 1,600 plus B squared, I don't know yet. 41 squared is going to be 1,681. At this point, this becomes like a regular equation that I need to solve for. I'm going to subtract 1,600 from both sides, draw my line there, just in case you can't see it. B squared is equal to 81. Now again, I'm looking at what value of B times the value of B, also known as B squared, because if I multiply those two together, B squared is going to equal 81. So I'm going to take the square root to figure that out. What number times another, that same number is going to be 81, and I know that the square root of 81 is going to be 9. So now, I know that this is 9 inches. Now I want to stress that these are not always to scale, and any standardized test that you take will say that. Now let's go and move on to the converse. Now here's the part of the video that we're going to be looking for the converse of the Pythagorean theorem. Okay. Now the converse is going to be whether or not I can look at three different values. Okay, and any number, any set of three numbers that work out to be valid in terms of the Pythagorean theorem are called a Pythagorean triple. So just like we saw in the previous videos, 30, 40, and 50, or first part of this video I should say, 30, 40, and 50 would actually work as a Pythagorean triple. But in this example, I need to figure out using the converse whether or not these three will satisfy that requirement to be a right triangle. Okay, so let's go ahead and take a look at these numbers. So I have the numbers 9, I have 12 centimeters, 9 centimeters, 12 centimeters, and 16 centimeters. Okay, so what I want to do at this point is I want to go ahead and set up a triangle to see if in fact they work. Now I'm going to assume that this is a right triangle until I am proven otherwise using the Pythagorean theorem. Okay, so I'm going to switch back over to my work. All right, so I'm just going to abbreviate Pythagorean theorem converse here. Okay, so I'm going to go ahead and first draw myself a triangle. Now again, I'm assuming that it is a right triangle, but I don't know that yet. I'm just going to write down my numbers. Now, why did I choose to put 9, 12, and 16? Remember, the largest number is always going to be assumed to be your hypotenuse, and I can interchange these. So I could have written 12 over here, I could have written 9, just as long as I associate them with one of the legs. Okay, now what I'm going to do is I'm going to start off by writing out the formula for the Pythagorean theorem there. Okay, so I'm going to then plug in the values. So I'm going to assume that this is A, this is B, this is C. Okay, so A squared, I'm going to put in 9 squared plus 12 squared must equal to be 16 squared. Now, if this side of the equation and this side of the equation are equal to each other, when I say equal to each other, both of these sides must simplify to be the same. If they simplify, excuse me, to be the same, then that means that they are valid in terms of making a right triangle. Now, if they are not equal to each other, that means that they just don't form a right triangle. They could form a different kind of triangle. All right, so 81 plus 144 is equal to, and I know through the magic of YouTube that 16 squared is going to be 256. Now, what I'm going to do now is I am going to calculate this, and I'll show you in terms of the calculator what that looks like. Okay, so let's clear our history. Okay, so hopefully this shows up, and I think that it does. Okay, so I'm going to go ahead and add 81 plus 144. That's great, you can see that really well. Okay, and I'm going to get 225 as my answer. So 225 is equal to 256. Now let's look at that statement. Is that correct? Does 225 equal 256? It does not. So therefore, I'm going to draw a line through my equal signs. And I'm going to say that this does not form a right triangle. Okay, so that does not form that. Okay, now had these numbers been equal, then of course it would form a right triangle. And that is the basics of Converse, of the Pythagorean Theorem. Okay, if you have any questions, please back this video up and watch it again. If you still are unclear, what I want you to do is I want you to come to class and ask those important questions. And if you don't get those questions answered in class, tutorials would be an option as well, 2 days a week. As always, you guys, I will see you tomorrow.